Hi everyone, and welcome back to my series on design patterns. When building software, sometimes we don't know what specific object we need until runtime. We want flexibility, separation of concerns, and a clean architecture. Enter one of the most popular creational patterns called the factory pattern. Creational patterns deal with object creation mechanisms, deciding how objects are instantiated. The factory pattern abstracts that process, allowing code to produce objects without specifying the exact class of the object that will be created. This in turn keeps our code flexible, scalable, and testable. And to make it digestible, we'll take a detour into sandwiches. Let's look at a real-world example. Picture a busy sandwich shop. Customers walk in and order different types of sandwiches. A BLT, club, veggie, chicken. Behind the counter, a sandwich maker doesn't care who walks in or what they ask for. He just calls the right method to assemble the sandwich. Now, instead of creating sandwiches manually in every part of your code, you just ask the sandwich factory. It takes care of the creation logic and hands you the right sandwich, whether it is toasted or wrapped, with avo or without. You don't need to know the details, just the results. This keeps your business logic clean and focused. Just like customers don't need to know how the sandwich is made, your calling code doesn't need to know the details of the object construction. I created a blank project for us to start from scratch. Step 1 is to create the interface. Let's create a package and call it interface. In that package, we are going to create a new interface and we are going to call it sandwich. In the sandwich interface, we are going to create one method for our concrete class implementation. This method will be called serveSandwich, and all the implementations need to implement some logic in this method. In step 2 of the process, we are going to create the concrete implementations. So let's create another package called concrete classes, just to group things together. Then we are going to add a new class called BLT sandwich. This is the concrete implementation of the interface. And here we need to implement the required interface and its methods, and in this case we just have the one method called serveSandwich that we need to implement. Let's go ahead and do that now. For our demo, we are just going to print some text just to say that we are serving a BLT. We're going to repeat this process and create another concrete implementation of the sandwich interface. Let's call this one veggie sandwich, just to stick with our sandwich shop example. Now let's go ahead and implement the required methods. And let's add some text in the method. And yeah, this is normally where you need to add your creation logic. Let me just put a comment so you guys know that for the future. In step 3 of the process, we are going to create our factory. So we're going to create a new package called factory where we can place our factory class. We are going to create the factory class and call it sandwich factory. We are going to create the factory method to create the right type of sandwiches we need at runtime. So create a new method with a static modifier and a return type of sandwich. We are going to name this method makeSandwich. It takes in one parameter, which is a string name type. And then we are going to define a switch statement to check the type as a lowercase to eliminate errors. And then our first case, we are going to say BLT, and we will return a new BLT sandwich. Our second case would be a veggie, which obviously then in turn returns a veggie sandwich. Then we have a default, meaning it's not one of the expected values. So in that case, we are going to throw an exception. I chose an illegal argument exception with a message, just to say unknown sandwich or type. Yeah, and in this case, you'll see I implemented it as in the old way of doing it, but IntelliJ is clever enough to give us the opportunity to convert it to the shorthand, so I will go ahead and do that. Step 4 is all about implementing the client code. So now let's move to the calling class or the client class and implement our factory. Here we are going to define a new sandwich, and we're going to call it sandwich 1. And we're going to call the static factory method make sandwich and pass in BLT for our switch statement. On the sandwich, we are going to call the serve sandwich method. And then we're going to define a second sandwich. We're going to call it static factory method again, and we're going to pass veggie as an argument for this sandwich. And then we're going to call the serve sandwich method on the second sandwich. When we run the code, we will see that the code creates sandwiches in the background, and when we call serve sandwich, it prints the correct message for each sandwich. So you'll see here that it says serving BLT for BLT and serving veggie for veggie. Good. Now let's go ahead and we will add another concrete implementation. And in this case, we will call it an Avo sandwich. Again, we will need to implement the interface and its required methods. Let's do that now. And again, in our demo, we are just printing some text to the console to indicate which sandwich is being served. In this case, Avo. So let's go back to our calling class. We're going to create a third sandwich, and we are going to use the make sandwich method to create one of type Avo. And we are going to call the serve sandwich method on it. Now I'd like you to pause the video here for a moment and guess what the output is going to be. As you'll see, we are getting the output for BLT and for veggie, but not for Avo. We are getting an illegal argument exception saying unknown sandwich. And in this case, that is correctly so, because we did not add the new option in our switch case yet. So it falls through to the default case, which throws an exception. So let's move over to our factory and add it to the switch statement. So we're going to add another case and set it to check for Avo, which returns a new Avo sandwich. We're going to rerun the code, and Bob's your uncle. We are seeing the output for Avo. All three our creation implementations are working correctly. And that's the basic idea of our factory class. Why is this useful? Because it keeps your code flexible, scalable, and testable. You can add new sandwich types or switch objects without rewriting the entire system. Your business logic stays clean and your sandwich shop runs smoothly. When do we use it? Use the factory pattern when you don't know what class you'll need until runtime. You want to centralize object creation logic, or you need to follow the open-close principle. open for extension but closed for modification. So that's the factory pattern, an essential creation tool in software design. Whether you're building sandwiches or services, this pattern helps you write cleaner, decoupled code that is easy to extend and maintain. If you're ready to level up your coding game and write cleaner, smarter software, then hit that subscribe button. Each week, we break down design patterns with real-world analogies, hands-on examples, and zero fluff. Whether you're a beginner or a seasoned dev, there's always something new to learn. So like, comment, and turn on the notification, because great architecture starts here.